Okay, this question is question 8 from January 2022 P4 paper. As we can see, it doesn't take a lot to work out. This is a vectors question. Let's read through it. So it says we've got points A and B which have position vectors 662 and 607 respectively. The line L1 passes through the points A and B. Write down an equation for L1. So just a little bit of teaching here. Sometimes it's a really good idea. It doesn't need to be accurate. Obviously, this is in 3 dimensions. I can't draw it out properly. But if they're telling me I've got some vector A, which is 662, this is the point 662, and some vector B here, there's vector A, and some vector B here, which leads to the point 607. If they're now telling me they want the equation of the line that passes through those 2 points, I now know what I'm doing, okay? When I've got R equals P plus lambda Q, P gets us onto the line, and then Q is the direction of the line. So in this case, R is going to be either vector OA plus lambda lots of AB, or it would be R equals OB plus lambda lots of AB. So in other words, what I need to do first of all is to work out what AB is, and once I've got that, I can use either of those ones to work it out. A quick sketch is always a really good idea with some of these vector questions, just to work out what we've got going on. So in this case here, AB, call that O, AB is going to be AO plus OB, so it's going to be minus 662 plus 607. Just improve my handwriting there, move that there. And what does that work out to be? That works out to be 0 minus 6, 5 here. So if I now want R is going to be equal to, you've got a choice of answers. I'm going to say 607 plus lambda lots of 0 minus 6, 5. And you could equally have put in 662 plus the vector. When I'm looking at this one, so that's the answer. When I'm looking at that, that's a point on the line. That's the direction of the line, and that might come into play in second part, third part of this question. So that's part A done. Part B, it says we've got another line which is R equals 314 plus mu lots of 159. And then what does it ask me to do with those ones? It says show that L1 and L2 do not meet. Okay, so basically what I'm going to try and do is show that they do meet, and then it won't work out. So if I'm going to try and do that, I would say if they intersect, if they meet, if they intersect, then 607 plus lambda lots of 0 minus 6, 5 would equal 314 plus mu lots of 159. And I'm going to put them equal to each other, the top, the middle, and the bottom, and get 3 equations. So I'm going to get, in this particular case, 6 plus 0 lambda. I'm going to go really slowly. 6 plus 0 lambda is equal to 3 plus mu. I'm going to get 0 minus 6 lambda is equal to 1 plus 5 mu, and I'm going to get 7 plus 5 lambda is equal to 4 plus 9 mu. Now, if you're confident at doing this work, you might choose the easiest 2 equations to be able to work out lambda and mu, and then put it into the other one. For my teaching, I always say to my students, just concentrate on 1 and 2, solve it for that. It's always just going to be an IGCSE thing, and then test it in number 3. So it makes it a little bit easier for them to remember the processes we're actually going through. Number 1 actually gives us it anyway. So number 1 gives us that 6 is equal to 3 plus mu. So mu is equal to 3. And if I put that into number 2, so from what, let's slow this down. From equation 1, we get that mu is equal to 3. Sub into 2. I've left 3 completely alone. I've done that on purpose so that that can be my check for the last part of this. So in number 2, I'm going to get minus 6 lambda is equal to 1 plus, in this case, 15. So lambda is going to be 16 over minus 6. So lambda is going to be minus 8 over 3. So every situation that I can think of, it is actually going to work for those first two. Okay, I haven't shown anything yet. It's checking it in number 3, which again is why I say that to my students. Check in number 3. This is to see whether it does actually work out. And if it does, and you work it out, you could then put mu into those 3 to find the point of intersection. We know this one isn't going to work out. So when I check this in number 3, 7 plus 5 lambda equals 4 plus 9 mu, it's not going to work. Let's still do it and take your time over it. So 7 plus 5 lots of minus 8 over 3 equals 4 plus 9 lots of 3. I'm going to get minus 19 over 3 equals 31. This does not work. So the lines do not meet. Not meet. We want to make that really clear to the person marking our work, that we know exactly what's gone on there. Worked in the first 2 but didn't work in the third one. Okay, so that's part B done. Part C says, point C is on L2 where mu equals minus 1. So let's work that out. Did I put a thing for B? I don't think I did. So this is B here. This is now going to be C. So R is equal to 314 plus mu lots of 159. And we're now saying for C, mu equals minus 1. So OC works out to be 314 plus 159. That was mu 1 or minus 1? Sorry, mu was minus 1, I do apologise. Minus 1 there, so that's going to be minus that there. That gives me 2 minus 4 minus 5. Okay, so that's my point C. And then what have we got going on? It says find the acute angle between AC and L2. Okay, so if I've got to find an angle between 2 vectors, what I need to do is to find those 2 vectors. So I need to find AC first of all. So AC is just going to be C minus A. So that's going to be, what was C? C is 2 minus 4 minus 5. And A from before was 6, 6, 2. So that gives me the vector minus 4, minus 10, minus 7. Wow, okay, they're all negative there. And if I'm looking at the vector L2, then what I'm interested in for the vector L2 is the direction of it, is the 1, 5, 9. So direction of L2 equals 1, 5, 9. So it's these 2 vectors that I now want to find the angle in between them, okay? Don't particularly need this, I'm going a little bit over the top here, but what I'm saying is if I've got the vector minus 4, minus 10, minus 7, and I've got the vector 1, 5, 9, then that's the angle that I'm looking for. Well, we're simply going to use, not got a little space here, so I might need to move things up a little bit. We're simply going to use the idea that A dot B is modulus A, modulus B, cos theta. I am actually going to get rid of my extravagant diagram, so I've got a bit more space to work in. So A dot B is going to be minus 4, minus 10, minus 7, dotted with B159 is going to equal to the modulus of A, so that's the square root of 4 squared, 10 squared, and 7 squared. Doesn't matter whether they're plus or minus because we're squaring them anyway. And the modulus of B is going to be 1 squared plus 5 squared plus 9 squared cos theta. So if we work out this first bit, just be careful with it, easy to make mistakes. This is minus 4, this is minus 50, this is minus 63. Is going to work out to be, that all works out to be root 165, and that all works out to be root 107 cos theta. And so cos theta is equal to one of them over the other one there. So that minus 54 minus that's minus 117 over root 165 root 107. So theta works out to be equal to 151.7 degrees. I'm assuming we want the acute angle. Yeah, find the acute angle between them. So no problem with that at all. I didn't try and mess around and work out which one was going to be the acute angle. If that's true, then the acute angle is just 180 minus 151.7, which then works out to be 28.3 degrees, and they wanted it correct to one decimal place. Okay, long question, but hopefully that will make sense.